Lesson 2 continued. Writing equations to model relationships. And here we're going to do some writing of equations using percentage. And so you can review page 2 of these notes here to remember how we work with percents in equations. So here we have a situation, and I encourage you to pause the video and try filling this out on your own after we talk about it here. We have a situation where you have a sales tax on a car in Michigan, which is 6%, and one of the dealerships in Michigan, Ann Arbor, Michigan, also adds on $120 in miscellaneous charges. So we're going to write an equation to figure out how much total we have to pay for a car whose original price is $9,500. So our total price is going to be the original price plus 6% of the original price. And percentages, when we work with percents in equations, we have to convert them to decimals. So 6%, the decimal for a whole number is written there, unseen. We have to move the decimal 2 places to the left, fill that in with a 0. So 6% written as a decimal is 0.06. Also, that's the same as 6 over 100. 6 divided by 100 is 0.06. So we're going to take that original price, multiply it by 0.06 to find the tax, and then we also have these $120 in miscellaneous charges. So if we do that math and add it all up, the total price we'll see is $10,190. All right, then we do that again, and now it's a more expensive car. So we'll do the same thing here, where we multiply times the percent, 6%, and the full price, and add 120. And if you work all that out, you get 15,794 cents. Okay, last one. I'll let you write that out on your own, but the full answer is 23,948.80 cents. Now we're going to write an equation if the price is P. So pause and see if you can do this on your own. Total price is going to be the original price plus 6% of the original price, 0.06 times P. So we're using, like this one here, we have the original price, P. The original price times 0.06 is here, plus these extra $120. Now, these are like terms. They're both have the same variable raised to the same power, P. So we can combine those. And remember, when a variable is written by itself, the other way to write it is putting a 1 as the coefficient. So here we have 1P plus 0.06. Combining those together would be 1.06P plus 120. Now 1.06, if we convert that back to being a percent, moving the decimal twice to the right, that's 106%. And that makes sense that we'd multiply the price by 106% because we have the 100% plus the 6% sales tax. Okay, the next one, again, I encourage you to pause and try this on your own. We have the class planning a trip to a museum, $7 a person, and the cost of the bus, a flat fee of $180. So figuring out what is the cost, if we have 24 students, they're each $7, plus 3 teachers, also $7, plus 180. And if we work that out, that's going to be 369. Now we have a different number of students and teachers. We might say, well, everyone's paying $7, so I'm going to multiply $7. First, I'm going to add up the number of students and teachers, and then multiply it by 7. So that'd be 7 times 34 plus 180. If you work that out, it's 418. And then the generic situation, where we have S for number of students and T for teachers. So we could just take our problem here, and we'd have C equals 7 times the number of students plus teachers plus that $180 for the bus. Another way to write this would be to say 7s plus 7t plus 180, right? So distributing the 7. Either of those would be acceptable. Okay, next page. Here we have a situation, another word problem. I encourage you to pause and try this on your own. So we have a plane departs from New Orleans. So here's New Orleans. And then it flies to San Diego. And at any given moment, we represent how far it is away from its starting point from New Orleans as x. So let's say the plane is right here, so this distance would be x. And then how far it is from San Diego would be y. So that would be like the rest of the distance here to San Diego. All right, so let's see what we have here. When we're 100 miles from New Orleans, we're 1,500 from San Diego, etc., etc. So we look at the pattern and we see, well, it looks like New Orleans and San Diego are 1,600 or 1,600 miles apart total. So if we are 1,020 miles from San Diego, we just subtract that from 1,600 to see how far we are from New Orleans. Same thing here. Here we've gone pretty far from New Orleans, so we're like pretty close to San Diego at this point. So I could just say 1,600 minus 1,450, and I would get 150. So now writing an equation to represent the relationship between x and y, miles from New Orleans and San Diego. I encourage you to pause and write your own equation. So one equation, we could express it like this. One distance plus the other is always equal to 1,600. Or we might say the distance from San Diego is equal to 1,600 minus the distance from New Orleans. Or we might say x equals 1,600 minus y. These are what we call equivalent equations. And so those would all be correct ways to express the same equation. Okay, lastly, pause, try it on your own. Company decides to donate to charity $50,000. It will select up to 20 charitable organizations as nominated by its employees. Each selected organization will receive an equal amount of the donation. Okay, so let's try this. We're always donating $50,000 and they have to get divided up by the number of organizations. So if just 5 organizations are selected, we got to take that 50,000 and divide it by 5, which will give us 10,000. So each organization gets $10,000. If there's 10 organizations, more people have to share the same amount of money, so each one only gets 5,000. And if they choose to donate to the 20 organizations, then that number is further reduced. Each organization only gets 2,500. Okay, last thing, we're writing an equation to represent the relationship between the number of selected organizations, N, and the dollar amount each of them will receive, D. So the amount of money they will receive is equivalent to this $50,000 divided by how many different organizations are sharing all this money. In algebraic equations, instead of writing the division sign, we usually use a fraction bar to represent a quotient. So this would be the more common way that we would see the equation written, like so. Okay, that's it.